All right. So, admittedly, because of two glaring issues, your algebra professor was vacant and they were having you being taught by a reading teacher for 4 months last year. And then also with this geometry teacher that doesn't really teach you guys, but expects you to teach yourselves, which technically not everyone's brain can do that. And I think yours can, but I'm just saying that's just a terrible teaching method. We're gonna have to play some catch up, right? So you're gonna have to lean into doing some extra work here for the next couple of weeks if we want to get caught up relatively fast to what he's teaching you and to what you also missed last year. Okay? Right. So I'll probably be giving you a good amount of stuff outside of session. If we looked at a circle, that's not a circle. Drawing a circle is hard. I'm gonna be honest. There we go. This is a perfect, beautiful circle. All right. What is the diameter of a circle?
I
Pi? No. The diameter of a
I
circle.
thought you said that's always the diameter.
What?
I thought you said that the ratio of the circumference to the diameter is always pi.
The ratio of the circumference to the diameter. So if we take the circumference, what's the formula for a circumference? Do you remember?
That's the longest paper.
Nope. So the circumference of a circle is 2 pi r. Now, the circumference, if I had to tell you what it was, is basically like the perimeter of the circle, right? So when you think circumference, think the pseudo perimeter of a circle. It's like the perimeter of a square, you're adding all the sides together. But in a circle, you can't add the sides together because you don't really have sides. You have arcs, you have curves, right? So the circumference of the circle is like the perimeter. That's why I say pseudo. It's not exactly the same, but pretty close. So we multiply 2 times pi times r. So what is pi? Relatively, like,
3.14.
exactly. So 3.14, and then it can go on, right? Pi is irrational. Pi is an irrational number, which means what? So pi being an irrational number is a number that cannot be expressed as a fraction. It will go on and on forever. So pi goes on to infinity. And then an irrational number is one is a number that can be expressed as a decimal, but not a fraction. And we simplify pi to say that it is equal to 3.14, but really it's equal to 3.1456 something, blah, 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 blah. And it goes on and on. Now, the ratio of the circumference to the diameter is always equal to pi. Before we can understand what that statement means, we have to understand what the diameter is. So the definition of the diameter of a circle is the distance from one end of the circle through the exact center to the other end of the circle. One end of the circle to the other end, this is the diameter. So distance across the circle through the exact center. If I took a line and went like this is from one edge of the circle to the other edge, but then I pick it up, try to place it on top of this, it's not equal to the same thing, right? So really what we're looking at is we're looking at the exact or the maximum distance across the circle. So the diameter, another way to define it, is the maximum distance across the circle. So the max distance, I'm going to abbreviate distance as DIST. Sorry, that's written a little crummy there. So the diameter is not listed in the circumference equation. But the radius is. What is the radius of a circle?
Like, what is it or was it equal? Is that rational or what is it?
Whichever one you're comfortable with, because I think they're related here. So what is it equal to? Let's do that. So it's related to the area. So the radius is half of the diameter. Okay. So it's equal to half the diameter. So aka you can write it as d divided by 2, right? So the radius would be this. Okay. So center of the circle out to the edge of the circle. Does this ring any bells?
Oh, okay, yeah.
Okay. So this is the radius, and then the white here is the diameter. Okay. So the diameter, if the diameter is equal to half, or if you multiply the radius times 2, you get the diameter. Or if you divide the diameter by 2, you get the radius. And let's just write that out. So radius equals diameter over 2. And this is just algebra that we're doing down here. We're just taking this formula up here. Radius equals diameter over 2. And then we multiply this side by 2. And we get 2r equals the diameter. Okay. All right.
Okay.
So now, in order to prove what he just said, which is the ratio of the circumference to the diameter is always equal to pi, now we have everything we need. Circumference equals 2 times pi r, and instead of r, I supplement in this formula, what I get is d over 2, and the reason that I'm trying to do that is because I'm trying to figure out what the ratio of the circumference to the diameter actually is. So then what I do is I do a little bit of manipulation here in this equation, and I remember back to arithmetic when any two numbers or three numbers multiplied by each other, right? If I go back, if I say a times b in parentheses times c, that's also equal to a times b times c, where b and c are now in parentheses, right? So this is equal to this, right? So we're going to move things around here in this equation to make it look a little simpler so we can simplify and get to that proof, right? So now the circumference is equal to 2 times d over 2 times pi, right? Now that we have 2 times d over 2, this cancels out. So 2 times d over 2 cancels out the denominator, right? So if I had 2 times d over 2, right? If I was to multiply this together, right, and then multiply this through, I multiply across the fractions, I get 2d over 1 times 2, right? So I get 2d over 2, which cancels out to just equal d. Okay? All right. So now what I get is very little room. Let's get rid of this. And let's move this up a little bit. So, continuing then, we get c equals d pi, right? The only thing we have to do to find the ratio is divide this side by d, and I get the proof that c to d, right, the ratio of the circumference to the diameter equals pi. Does that track? Does that make sense?
Yeah, I'm just trying to write it.
Of course. Yeah, go ahead and write it down. Let me know when you're done and if you have any questions.
Is the third one B in pi over D?
Which one? The third one being this?
Yeah.
Sorry. This one?
No,
The next one down? Yes, it's c equals d divided by d equals pi because this is just me solving it algebraically. So then I need to divide that left side also by d, and I just didn't put that in there. So I'm dividing by d and I'm canceling this out. Now I have this final relationship, which is c divided by d, aka the ratio of C to D, aka the ratio of the circumference to the diameter, is always equal to pi.
Okay. We don't really get, cause my mom wants to have my dad is not.
No, I shouldn't say he's feisty. He's fat, actually. And he likes things a very certain way, and we don't know what that way is. So we're just trying to figure it out.
And I had cats like growing up on her whole life, but my dad does not like cats.
Yeah.
He likes dogs.
I like dogs too. I think both my girlfriend and I are in agreement about that. But when you have a small apartment, our apartment's not that small. It's pretty big, but we just don't like the dog that we want is a giant Alaskan Malamute, and they're huge. Yeah, we can't have them here. I should say the dog that I want, because that's really my goal. My girlfriend would probably go for a smaller dog. Not small, but not giant. Medium.
We used to have a dog. We don't have a dog anymore. We used to have a Yorkie though.
Yeah, I thought.
Okay.
Okay. Does the note that he had you take there, which is the circle, is equal to the ratio of the circumference to the diameter is equal to pi? Because all I have here actually is the ratio of the circumference to the diameter. I don't actually have equal to pi, but it is on the note that you sent me. It only says the ratio of the circumference to the diameter. Do you see that?
Yeah.
Yeah. So it is equal to pi though. Now what I want to do is take a look at this next one, which is the ratio of the circumference. Oh, it's on the next page. What?
Yeah. He would, okay. He would write something and then he'd be like, next page or new page. He'd be like, when I tell you new page, you just write a new page. So we wasted a whole bunch of paper today because he didn't let us write everything on the same page. He didn't say it. He just said,
I know he didn't say that, but looking at it to me, he either
yeah.
wants you to prove it or he's going to do it in class. But based on his teaching style, he won't do it in class.
There
So I
actually
think,
makes that make sense.
yeah,
But he did.
that's all right. We'll prove it here in session. So if we do,
Wait, change the page. Why we get a new page?
yeah, go ahead and get a new page here, whatever you think is best, because now we're going to prove this here. We're going to prove this other one. I'm just writing the triangle backwards. I could flip it, but I'm not going to. So this is something that we just did. What is this?
Triangle.
Correct. It is a triangle.
30, 60, 90 triangle.
Yep. This is going to be a 30, 60, 90 triangle. So we're going to have on the hypotenuse, we have x radical 3. This angle up here is going to be equal to 30 degrees. This angle down here is going to be equal to 60 degrees. This bottom is what we're trying to figure out. Wait, I'm sorry. I wrote that wrong. I'm writing it backwards. So the hypotenuse is equal to 2x, and the other side, the longer side, is equal to x radical 3. Sorry about that. And what he says here is the ratio of the long side in a 30, 60, 90 triangle to the short side is 2 to 1 or 2 to 1 or 2 over 1 or 2, which is not true. The longest side, I would say, but usually when people talk about the long side, they're talking about the long leg. So this is the long leg, and this is the longest side, being the hypotenuse. So if he's talking about it like this, the longest side, which is the hypotenuse, then he is correct. But if because this is equal to x down here, but if he's talking about the long leg here, which is how everyone usually teaches it, the long side in a 30, 60, 90 triangle, this should really be the longest side, aka the hypotenuse, right? So this is the hypotenuse. This is the language that we use in geometry because now we know what we're talking about. So he should say the hypotenuse, the ratio of the hypotenuse in a 30, 60, 90 triangle to the shortest side or the short leg is 2 to 1. So the wording here that he used is a little confusing. But technically, it is correct if this is what he means. But it's ambiguous, that is, it's not clear in the way that he worded this. So I just want to make sure that I'm clear so that you understand what he's saying. Okay? All right. And this is why we use crazy words like the hypotenuse and legs of a triangle because it's better to be clear and concise than to be confusing and expect the student to figure it out, right? Because you need to know the information before you can apply it to higher order problems, right? To more complicated problems. So, does this statement make sense here? We don't really need to prove it unless we can use the Pythagorean theorem to prove it if we want. Okay.
He
So this,
saying he doesn't. He's really against the Pythagorean theorem. Actually, I
yeah, I don't know why either. It's a great formula. But if you don't want to prove it, that's fine. But you can use the Pythagorean theorem to prove that this is true.
yeah.
One, two. Let's just take a look at it really quick. So the Pythagorean theorem is a squared plus b squared equals c squared. And in this triangle, say a is equal to the short leg and b is equal to the long leg and c is equal to the this. I'm just going to abbreviate that as height. So what we're trying to prove is that x squared plus x radical 3, the quantity squared, equals 2x quantity squared, right? Because that's what we have here. So what I'm going to do is I'm going to supplement in for a. I'm going to say, all right, let's just say a is equal to 1. C is then equal to 2 based on the 30, 60, 90 formula below, right? 2x. So this is 2 squared, right? Because a is equal to x and c is equal to 2x, right? According to the 30, 60, 90 rules. What we get is 1 plus b squared equals 4. And then we get subtract 1 from each side, and we get b squared equals 3. Then we take the square root of this side, the square root of this side, and we get b equals the square root of 3, which is what we have below. And that proves the 30, 60, 90 triangle. It's really simple. It's actually really beautiful. When I plug in 1, I get this minus this, which is 3. Then I take the square root of both sides, and I get b equals 3 squared. So then I have a proof that shows if a is equal to x, right, and c is equal to 2x, then b is always going to be equal to that thing, x, times, right? Because if I just multiplied 1 here, it would be, that would be x times the square root of 3, right? So it's a very easy proof when you use the right thing, which is the Pythagorean theorem to prove it. Yeah, for 30, 60, 90 triangles and 45, 45, 90 triangles, I would agree that it does take up more time than just using the ratios. But when you're trying to prove something like this and see it and understand it at a deeper level, this is the only way to do it. Okay, so let's look at this last one really quick. So what is m supposed to be equal to? The measure of the angle, I'm guessing?
Oh, he was trying to prove because in the beginning, like he asked everyone what he must get like a piece of paper and like he said draw a line of line at A to B, and most people drew a line segment and not actual line.
So this is the measure of the angle, right? So this is the sign for angle. And this is flat, and then this comes up like that. So just FYI, this isn't an inequality sign. It looks like an inequality sign in your notes here. So just be aware that's not what we're saying. We're saying the measure of an angle DCB. He hasn't defined M at all on here. If he was going to do that, so usually, typically, when we see M in geometry, it's the measure of an angle. But there is no definition of M here, so we can't really say that. So in geometry, whenever we have measure and then this sign here, this should be an angle, right? Maybe he was misreading his notes or something. But 9 times out of 10, that's what it means in geometry. So then, what he also has here is the measure of angle ACB is equal to pi radian. And I hate to be just like a teacher, but we don't have enough time to prove this. So I'm gonna have to send you a video of this. I'll send you a video explaining this. But what I think he was showing is for this next part here. So the measure of the angle BCD then is less than, which is terrible to use that symbol with geometry, but it's like the only one that we have, is less than the measure of the angle ACB. Yeah. So the measure of the angle BCD is less than the measure of the angle of ACB. So kind of like we talked about, I think we talked about this. Like when we have a straight line like this, technically C is a point, so there's an angle here of 180 degrees. So that's the angle. So when I say that the measure of, and whenever you have something written, just FYI like this, DCB, the middle number is where the angle is, right? So DCB, we're talking about this angle right here. Does that make sense?
Yeah.
So DCB, the measure of the angle of DCB is what is the relationship, question mark, what's the relationship between that angle and the measure of the angle of BCD? So they're equal to each other is the answer. Because DCB and BCD are the exact same angle. Okay? So these are equal to each other. So radians are another way to measure angles in geometry. So 180 degrees is equal to pi radians. Right? Do you understand that? Does that make sense? Okay. So we'll talk a little bit more about that. And then basically then, so when we have the angle BCD, this angle, and then we compare it to the measure of the angle of ACB, ACB, this angle, right? So it means that this angle is less than this angle, right? So 180 degrees, or sorry, 90 degrees is less than 180 degrees, aka in radians, pi over 2 is less than pi. So degrees versus radians. And I'm going to have to cover the rest of this with you. I'll send a video over in addition to what we did in session today and on Friday. Okay. So just you know how shoe sizes are different in America versus like Europe? Yeah. So you can think of degrees as like American shoe size and radians as like European shoe size. So they measure the same thing, but they just do it with a different standard.
Okay.
So like in Europe, my shoe size might be 45, but in the US, it's 10 and a half, 11. Okay.